Currently in the Pacific Northwest, it is summertime. It's a lovely 90 degrees Fahrenheit outside today, and in here, it's 86. By the way, podcast mic hot take, Fahrenheit is the superior temperature scale. 90 Fahrenheit is 32.2 repeating Celsius. That's just silly. Fight me in the comments. Anyway, this office is a bit of a convection oven, and I personally just don't do well in the heat. Fortunately, there's a not-so-secret weapon on our side. My 3D printer farm from studio sponsor and sponsor of this video, Prusa Research. Combine that with my YouTuber level of overcomplication and overconfidence, and I think we can fix this problem. You see, out here in the main space of the lab, we just got 2 AC units up and running. It is a lovely crisp 75 degrees Fahrenheit in here right now, which I don't think is too bad for a concrete and metal box in the middle of the summer. Meanwhile, back here in the office, I have this window AC unit in the wall that is loud, so I can't run it while I'm recording. It's inefficient, and worst of all, it dumps its heat out here into the warehouse, which I am paying to cool down, thus fighting me and costing me more. That's where this pile of parts and 3D prints comes in. The farm has been pumping through kilograms this week, and I think we're ready to solve this problem. Let's go take a look at the design that's going to semi-passively cool my office. The core concept is really straightforward. We just need thermodynamics to work for us. It's a pretty reliable thing, so I think we can make that happen. The main lab space, aka the big open warehouse right on the other side of the wall from the office, is actively cooled by 42,000 BTUs of air conditioning horsepower. So in the office, we're going to use that to our advantage by putting vents in the ceiling that'll then allow air to be drawn in through a filtered inlet in the wall between the office and the cool space. That'll bring cool air in, exhaust hot air out through a whole silencer assembly we'll talk about in a second, into the shop to equalize the temperature everywhere. That silencer assembly is going to be mounted up in the loft above the office with a fan inline in it. The idea is to create a negative pressure in the office to be replaced by cool air, but to keep it quiet, because at the end of the day, I'm a YouTuber who doesn't like normal sounds. There's plenty more to talk about in this design, but we'll cover that as we print and assemble parts. I'm going to start with the silencers since they require some hands-on effort. I need a pair of 12-inch tubes for these, and even I realize that's silly to 3D print those. So off I went to Lowe's to grab a 12-inch concrete form tube. It's rigid, affordable, and big enough to fit 2 inches of insulation without restricting airflow. I'm going to cut this 4-foot tube in half so I can use it as a pre- and a post-fan silencer. And then I need to hit it with a coat of paint because the branding on it is not going to fit with my slowly emerging studio aesthetic. While the paint dries, let's talk about the fan we're going to use. This is the Vevor 8-inch inline fan. This is clearly a clone of an AC Infinity fan, but it costs less than half as much as a similar sized unit. It's rated to move 807 CFM at full speed, and this version comes with a smart controller. It also has a thermistor for temperature reading, so it can be controlled manually or it can be controlled via temperature, which we will be using to automate this setup. It does vibrate a bit more than the higher end unit in my experience, so I picked up some 8-inch vibration isolating couplers to decouple it from the rest of the duct assembly. That said, it's not that loud and it does move some serious air. Just a quick PSA for you, I did purchase this fan, it was not provided to me for this project, and I am glad it costs less than half the price of the more expensive one because I've had to purchase it twice now. FedEx marked the first one delivered over a month ago at this point, and I've been going back and forth with the Vevor store since because I never got it and I've yet to get a refund. I asked for a replacement rather than just giving me my money back because I still needed the fan and I've yet to get anything from them. I ended up having to buy it again just so I could do this project. It also has a lower quality feel to it than the AC Infinity fans I've had experience with, so I think I'd probably recommend just paying the extra money. The next project I have planned, a whole studio fume extraction setup, I'll be doing that. So there's a link in the description to an AC Infinity fan, not to this one, because I don't know if I could recommend it. Alright, rant over. With the silencer tubes painted, it's time to assemble them, which means I need 3D printed parts, and a lot of them. This is the kind of project I might have written off in the past as too big to justify. I once did an entire video about one AC vent. That's only a portion of this project. But with the Prusa print farm, printing the parts was almost the easiest part. I mean, almost. This project was like 10 kilograms worth of filament, but honestly, that's the only real downside. Sure, I've had access to a bunch of machines over the years, but I've never had this kind of reliability. Multiple copies of the same machine means slicing is predictable, results are consistent, and I spend way less time babysitting printers and more time just building real solutions. This is making 3D printing even more of a functional shop tool for me, and making my future projects look even more ambitious. Of course, for the scale of the silencers, the Prusa XL came in clutch on those parts and made me wish I had one or two more of these machines. The prints made for some epic print bed cracks. So with our end caps printed, our tubes painted, it's time to get these silencers built, which means I need the material that's actually going to sound dampen these. I've got this rock wool insulation, 2-inch by 48-inch sheets of it from projects at the last house that I never got to. So I'm going to use this to line the inside bore of this 12-inch tube, which 2 inches of insulation means we'll be necked down to 8 inches, which is the size of our fan. Figuring out how big of a piece I need is simple. It's pi times the diameter of my tube. So one of those times where having the big calipers really pays off. The inside diameter of my tube is more like 11 7/8 heavy, which 11.9 inch times pi equals 37 3/8 of an inch if I'm rounding down just a hair. These sheets are 48 inches long, so I can easily cut down 2 of them to make 2 silencers. They're 2 feet wide, which is the length of my silencers, so I don't have to cut them down that way. And yes, I did make sure Nori's in the office while I'm cutting these. I don't want her around this rock wool while I'm cutting it. Which is then followed by carefully scrunching this up to the inside of this tube and getting it to all press in here. The first printed parts we're going to install are these orange ones. These are the mounts for the actual silencers, which are actually going to hold the fan in place too. You'll see that later. I designed these to span on a stud bay. I checked where I intend to mount these to make sure that was going to work, and it should be fine, and they'll mount directly to the outside diameter of the tubes. I designed this bracket to be split in the middle with a key in the center just to align it so I could glue the 2 halves together. To glue it, I'm using CA glue and a shot of accelerator just to get it to set really quickly. To align the mounts on the tubes, I'm placing them flat on the workbench. I've already spaced them as far apart as I want to, and now they should be on the same plane with the silencer tube. So I can just pull it off the edge and run a screw up into it. With those mounting feet in place, we can put on the end caps for the silencers. Each end cap is different depending on where it's going to be. This is the outlet for the silencer before the fan. It's just a smooth adapter to the fan inlet diameter. The one that goes into the pre-fan filter has a little bit of a guide tube to help guide airflow into the center of the insulation, but it also has some cutouts so that sound waves and some air can actually just penetrate into the insulation, hopefully helping the effect. I think some of my previous videos have really shown that my scientific backing when it comes to sound deadening and such is whatever seems like a good idea to me. So that's what I'm going with here. To seal the end adapters onto the silencer, I got some just black window silicone that I'm going to apply around the inside edge of each of the adapters so it can seal to the silencers. I don't want air leaks coming out of these, and trying to get them in exact tight fit was just silly when I could do this. The cone with the most drastic difference is obviously this one. This is the outlet from the silencer after the fan that's going to shoot out into the studio. So it's making the first half of the 90-degree turn out into the shop, but it's otherwise open and free in here. So it's a nice smooth transition. I don't want turbulence adding to noise. Oh, by the way, if you hear like a little bit of cracking sound as each of these is going on, the print is fine. There was an inner and an outer brim on each of the prints, and I left the inner brim in place when I installed each of these, so it kind of acts as a bit of a wiper helping to seal things up. I just didn't see any reason to remove it because it could provide ever so slightly a tighter fit. And with that cone on, we've got a pair of silencers. These are straight through designs with insulation in there, but shouldn't restrict my airflow or create turbulence that then creates sound itself, but should allow for some form of damping. I could be entirely wrong. This could be a total waste of time and money. Who knows? This mounting flange on the outlet has a couple of design details we've yet to discuss. It's got this raised lip flange all the way around the opening that's going to interface with the next piece of the ducting that's going to come off of this, and it has holes for heat press inserts. I'll use a soldering iron, brass threaded inserts, put those into here, and then the next part can bolt onto this. Continuing the rest of the design discussion, it's time to talk about the parts that got printed on the Core One and Mark IV print farm, because they're different. These parts are pretty big and mostly filled the volume in one way or another. They just look a little small compared to what we just printed on the XL. The whole idea was I designed whatever part I needed, but I split it into printable sections that would then bolt together afterward. So same concept as that mounting flange and lip on the outlet of the silencer. Each of these pieces has mating faces and then overlap areas to help seal the pieces together. Let's start putting this mess together, and I think it'll make sense. We'll pick up where we left off with the elbow coming out of the silencer. This is a 45 degree that's split in half for printability. One half receives some heat press inserts so that the other half can then be screwed to it. There is a little overlap lip between these two to help seal one half to the other, and there are 4 M3 screws holding the two halves together. The one part didn't print well. This is absolutely a slicer setting issue. I probably ran this part too fast so I could move on to something else. I don't exactly remember, but with that, there's a bit of a gap where the sealing lip got a little messed up. This gets bolted onto the outlet of the silencer with 3 M3 screws, and then sealing up that mess, some more of that silicone that I used to seal the silencer end caps. This will be fine to caulk up the gap and just clean this up a little bit. It's not like it's under severe pressure in the system. The next part we'll work on is this 90 coming from the office toward the silencer. It's made up of 4 parts, 2 halves of a 90 split into halves. Now this has a weird groove in the base of the flange. The reason is that this prints best in this orientation, with that flange against the bed. So there's nowhere to put the raised lip like I did elsewhere. So instead I used the wonderful extruder and printed a TPU gasket. The groove had to be deburred, and then I'm able to slip the gasket into its place. I used a little CA glue and activator just to hold it while I was lining up the 2 components. I did end up putting a little silicone inside of here because I had some left over, and why not? I could probably ramble on about design details for an entire video, but we should probably get to installing these parts. Some of it's going to make more sense in context. If you're the kind of person who does want the full design deep dive, I'll cover more of that in the post-episode debrief for YouTube members and Patreon supporters, where we break down what worked, what didn't, and what I do differently next time. Please consider checking out the links in the description to help directly support this content, get access to those debrief episodes, and other behind-the-scenes content. I'm going to begin the install process at the beginning of the airflow path, the inlet filter coming through the wall into my office that I have to cut in. Here's Alan. On the shop side of this inlet, there is a 3D printed housing that'll hold a 14 by 20 inch filter. I can already tell you that this is a good spot for this inlet to be. I only really picked it because it's the opposite end of the room from where the fan's gonna be, but there's a pocket of cool air in this corner, and it's trying to come in here right now while I'm speaking without any fan aiding it. Perfect. The next concern is sound waves just traveling right through this opening, so I designed this vent that will cap off the opening, and it's backed with 2-inch rock wool insulation inside, and then it's faced with a piece of this PET sound insulation that will eventually cover this entire wall, so it blends in a little nicer. I absolutely took the idea, the inspiration for this from my bathroom ceiling vent. The next thing we're going to install is the vent into the office. For that, I made this quick template that has the bolt positions for where the screws are going to be for that, the inner opening, so I can mark that out on the ceiling, and a center point hole mark so that I can drill up through and locate in the loft where the vent is going to come through. And that's the face of me realizing there's a water line directly above where I thought I was going to put this vent. So I've relocated it, moved it to a new position. I was able to shift it over just enough that the flange of the vent should cover the hole I just drilled, and I will have to patch the exploratory hole I put in here previously. With the hole figured in the proper location, I can jigsaw out the opening for my vent to pass through, and multi-tool out the drywall to give me an opening to put it into. The vent's a little larger than 8 inches to not restrict airflow, and I designed an adapter cone that's going to reach up to the loft. Okay, the next step, I screwed up, but I got lucky. I designed this vent coming up through the loft floor to go to this flex duct. Then it would go to this 90-degree turn toward the silencer assembly. But I got the dimensions wrong. So this 90 actually just slips over that vent, which honestly is a better situation anyway, and I think I'm just going to roll with it. It does mean too that this gets a little lower, so I could probably build a platform over this and get back some of my storage space that I was expecting to lose under the shelving unit. So I'm not upset about that. Before I put any of the rest of this up there, I want to mock it up here on the floor and lay it out, because my 3D model of the entire studio is not 100% accurate. I know that. And this all looks like it's a really tight fit where it's gonna end up from the floor to the ceiling height. So I need to know that before I go mounting things to the wall and realize I don't have enough height up there. It is just over 9 feet tall. All right here in between the shelving unit and this ancient hot water heater that's ballooned up, and I'm trying to get the landlords to get it out of here, is where we're going. And my microphone died, but it's gonna fit, so let's get this installed. I did end up having to put a couple of 2x4s on the wall just because stud spacing is extremely strange above this height, but otherwise these lined up how I expected and bolted up pretty easily with standard construction screws. You can see the silencers are actually holding the fan in place, and with the mounts on them, I feel confident this is going to work out. I had to remove the bottom brace off of the shelving unit to get this duct to be able to fit through here. And then I also had to mark for a small vent that I'm putting in the bathroom, but I'm not going to show you cutting in another vent. Connecting the office vent to the splitter on the bottom of the silencer is going to be some flex duct, and just stretching this out as much as I can to try and reduce the convolution inside. Each part is slightly isolated from one another, so hopefully vibrations won't translate from any one part to another. And that is the inside before the fan, getting into the pre-fan silencer, up into that Vevor fan, and up to the post outlet, which is going to go through yet another piece of flex duct. This is definitely a moment where I'm happy that a sole proprietorship does not fall under OSHA strict guidelines. And with that, this setup is done for now. Let me come down and explain. Originally, I had every intention of capping off the vent with a duct that would guide airflow out into the space. For right now, I'm just gonna deadhead it, because overnight I failed a print on that outlet. My fault. I thought I had a 0.8mm nozzle on a tool head that I did not, and it just didn't work out. So we need to test this whole system and see if any of this effort was worth it. Today's a little bit cooler day. Outside right now, it's 84 degrees Fahrenheit. In my office, it is 79.7 degrees. In the bathroom where the server rack is, it's slightly cooler at 77 degrees. You might think this is counterintuitive, small room with a server in it. But the window heat load in the office, the computer, my workstation that's doing more work than the servers generally are, that generates more heat, I find. Meanwhile, out here in the studio with the air conditioning kicking, it is currently 73.9 degrees Fahrenheit. We've definitely got a good temperature differential between here and my office. it's time to test our airflow system. To give an accurate representation of my daily life in here, I'm gonna work on editing this very video, so I've got that heat load of myself and the computer actively in this space while we're running this test. It's actually warmed up a little bit to 81.3 degrees Fahrenheit now, so I'm gonna go turn the fan on, which I currently have to go upstairs to do, but when I fire that up, we'll see how it sounds and how much it drops the temperature in here. I can immediately say that I actively feel air coming through around this vent, like an AC duct blowing at low speed, but active. It's working. Two hours of video editing and testing later, how is it? Well, it's not a total game changer, but it's definitely better. When we started this, I think it was at 81 degrees. It's currently 75.4 in here. Now, that is a 6-degree temperature drop just from running this system here, and I have a thermometer in the inlet over there. Air temperature coming in, God, it feels really good right here. 72.9 degrees Fahrenheit coming in around this right now. So obviously we're drawing in cool air, but where I'm sitting right now is the warmest spot in this office. I was hopeful that putting the vent inlet over to that side of my desk, and with the exhaust being the opposite corner over there behind the camera, that it would create a draft past me as I sit here. And it may be doing that. The air conditioner above my monitor is at 74 degrees right now. The heat doesn't seem to be rising to it the same way you would expect it to, or it normally does. The heat output of this 48-inch OLED TV that I use as a monitor and my computer, it's just probably too much and creating a bubble of heat around me. The shop door here going out to the workshop has a gap underneath of it, so I can feel cool air coming in through there and going right to that exhaust, really bypassing a lot of the room. In fact, sitting right here, this is definitely a slightly cooler spot. I need to put a gasket there to force more air to come in through that filtered inlet where I want it, control the airflow the way I intended. Now, what about the sound level? Standing underneath this vent, subjectively, I'd say it sounds like a home HVAC system lightly blowing, so reasonable. Let's check it with the decibel meter. 2 feet away, pointed directly at it, we're right around 37 decibels. With the fan turned off, the room tone level is around 32 to 33 decibels. Out here in the studio, I don't even think the microphone's picking it up right now. I could probably really boost audio and maybe you'll hear it. If I had to describe the way it sounds like my neighbors flushed their toilet or ran their sink. I hear that through the wall sometimes. It's that same sound. And I don't think that the microphone's gonna pick it up. And even if it does, it's such a consistent tone that noise reduction will easily cut it out. Was this worth it? I think so. I hoped for better, but I got what I expected. I know that room should have a dedicated mini split. I am aware of that. However, when I went to buy the AC for this warehouse, that was over $2,000 additional dollars just in hardware, let alone installation costs, which, being a commercial building, long story, but I had to pay somebody to help set up this stuff, and it wasn't cheap. If you count the filament in the parts list for what I built here, which I didn't buy this filament, I used the spools that came with my print farm, each one came with 1 kilogram, that's what I used up to build this. If I include that filament cost, this was $500. I got a 5-degree temperature drop for 1/4 the price of the AC setup. Sure, I'd like the AC setup, but for the moment, I'll live with this. I do believe that's where we're gonna wrap it up for this one, folks. I'm really happy with the way this turned out. Could have been better, but honestly, a 3D printed contraption that's cooling down my office, I will take it. I want to thank video and studio sponsor Prusa Research, whose 3D printers and filament make projects like this possible, and studio sponsor PCBWay, who offer excellent PCB manufacturing, CNC, and 3D printing services for your needs. Prusa for when you want to build it, PCBWay for when you don't. All right, folks, that's where we're going to wrap it up for this one. I hope you found it interesting. Let me know what you think in the comments. What did I do wrong? What should I do to cool my office better? I'd love to hear it. Get subscribed to ensure your 3D prints don't fail. It's not a guarantee, but it can't hurt. See ya.